So we continue with example 11. Okay, RC circle with EMF. Okay, so the given information, let me explain the given information. So the given information, the capacitor's value is 0.30, C is 0.30 microfarad, and the resistance, total resistance R is 20 kilo ohm, and the EMF of the cell or battery is 12 volt. Okay, so first for the A part we have to find the time constant tau. So the time constant T is the product of resistor R and the capacitance C. So the value of the R is 20 into 10 to the power 3 ohm, and value of capacitance is 0.30 into 10 to the power minus 6 farad. Now we multiply, we get time constant, that is 6.0 into 10 to the power minus 3 seconds. Okay, now for the part B, we need to find the maximum charge. So the maximum charge Q maximum is equal to C and the EMF maximum. So the capacitance is 3 into 10 to the power minus 7 farad, and into EMF is 12 volt. So we multiply, we get 3.6 into 10 to the power minus 6 coulomb. So that is equal to 3.6 microcoulomb. So the maximum charge developed is 3.6 microcoulomb. Okay, for the part C, the time it takes for the charge to reach 99% of this value. Okay, so we need to find the time at which the charge Q is equal to 99% of this value, the maximum charge. Okay, so in order to find the charge 99 maximum, so Q is equal to 0.99 times the total charge. Total charge is, as we know, that Q maximum, and the Q maximum is equal to, we know that 0.99 C, that is equal to, Q is equal to 0.99 CE, that is equal to 0. CE, that is equal to CE, which is equal to 1 minus E power minus T over RC, because we know that the value of the charge Q is equal to this formula for charge is equal to Q is equal to EC1 minus E power minus T over C, and the charge Q is equal to 0.99 C. If we compare these two equations, so we get this formula, 0.99 C is equal to EC1 minus E power minus T over C. Okay, CE will be cancelled, or EC will be cancelled, so we are left with the 0.99 is equal to 1 minus E power minus T over RC. So E power minus T over RC, which is equal to 1 minus 0.99. 1 minus 0.99 gives us 0.01. So we can find logarithm to log of E power minus T over RC, which is equal to 0 log of 0.01. Okay, so that will give us minus T over RC, that gives us this negative minus, sorry, not log of 0.01. so if we took this negative to the other side, so we get T over RC, which is equal to minus log of 0.01. so this will give us T over RC is equal to 4.6. so T is equal to 4.6 into RC. So the RC is, we know the value of RC is, RC product of RC is 6 into 10 minus 3. So T is equal to 4.6 into 6 into 10 to the power minus 3. So we get T is equal to, so the value of T is equal to 28 into 10 to the power minus 3. 28 into 10 to the power minus 3 seconds. So this is very small time, 28 millisecond. Okay, now so again repeat, so we use Q is equal to CE, Q is equal to 0.99 of Q maximum, or Q is equal to 0.99 of CE, and we also use Q is equal to CE1 minus E power T. So if we compare these two, we get this value. Okay, for the D part, the current I through the, so when its value is half, So when charge becomes half, so we need to find the current I. So the total charge is 33.6 microvolts, so it must be the equal to half of this value. Half of this value is 1.8. okay, so we use this formula, I is equal to 1 over r e minus q over c, but we put q instead of, we put q 1.8 10 power minus 6. So the EMF is 12 and the R is 2 into 10 power minus 2 into 10 power 4, and the value C is 0.3 into 10 power minus 6 farad. So we get 300 microampere. Okay, for the part E, the current is maximum, there is no okay, now for the part E, the maximum current, we need to find the maximum current. Okay, so when the current is maximum and the charge Q is 0, when the charge Q is 0, so the current is a maximum. So the we use formula I maximum is equal to E over R, so that the EMF is 12 volt and the resistance R is 2 into 10 power 4. So this will simple use Ohm's law, V is equal to IR and I is equal to V over R or E over R. So for the part F, for the part F, the charge Q when the total current I is 0.20 of its maximum value. Okay, so the when current is 0.20 of this maximum current, the above we found. Okay, so that the Q is equal to, so the I is equal to 0.20 times of the I maximum. So the I maximum is, in the previous part we find I maximum current, that is equal to 600 microampere. So if you multiply 0.20 into 600 into 10 to the power minus 6, so we get we get I value of the I, that is equal to 120 into 10 to the power minus 6 ampere, that is equal to I is equal to 120 into 10 power minus 6 ampere. Now we put this formula I in this equation, Q is equal to C into E minus IR. Q is equal to C into E minus IR. Q is equal to C into E minus IR. So we have all the values. So capacitance is given 0.30 into 10 to the power minus 6 farad, and EMF is 12 volt, minus current is, that is equal to 120 to 10 to the power minus 6 ampere, and we put multiply with the resistance R, that is equal to, resistance R is 2 into 10 to the power 4 ohm. So we solve and we get 2.9 to 10 to the power minus 6 coulomb. So this is the formula for Q. Q is equal to C into E minus IR, because we know that the Q is equal to CV and V is E minus IR. So we can, basic formula is Q is equal to CV and V is equal to E minus IR, because we don't know directly the V. So we can put E minus IR. So V is equal to E minus IR. So EMF is EMF, I is current and R is the resistor. Okay, thank you.